In this video, we're going to talk about a few topics from section P1, and the first is exponential notation. So when we have an exponent, we have a base b and the exponent or power n. And what the base means is that's the number that's being multiplied. The exponent means that that's how many times we are multiplying b. So b appears as a factor n times. So we say b to the nth power or the nth power of b. If we have an exponent of 1, anything to the first power is always itself. So any number to the first power would be equal to whatever that number is. So for example, 8 squared would be 8 times 8. 8 multiplied by itself 2 times, which is 64. 5 to the third would be 5 multiplied by itself 3 times. 5 times 5 times 5. If I do that on a calculator, I get 125. With negative numbers, we have to be kind of careful. If we have a parenthesis around the negative number, then that means that we're multiplying the negative number by itself that many times. So negative 2 multiplied by itself 4 times. Now, when we multiply a negative times a negative, that always equals a positive. So we can think of this as doing negative 2 times negative 2, that equals positive 4. And if we multiply this negative 2 times negative 2, that also equals positive 4. So my answer here is positive 16. If we don't use the parentheses, then what we mean is that we're multiplying 2 by itself 4 times, and then we're making the answer negative. So 2 times itself 4 times is 16, and then we make that negative. So this is equal to negative 16. So you just want to be careful when you're dealing with negatives. The next thing that we're going to talk about is order of operations. When we do order of operations, we start within the parentheses that are the most inside and work outwards. If there's a fraction, we do the numerator and denominator as if they were each enclosed in parentheses. So you would simplify the numerator first, then simplify the denominator, and then simplify the whole thing. We do exponents second, and then perform multiplications and divisions as they occur working from left to right. This is important, and it's something that a lot of people get confused on because they're thinking of PEMDAS, where M comes before D, and it's not always the case that multiplication would come before division, because you do multiplication and division together from left to right, and we'll see an example of that in a minute. Same thing with addition and subtraction, as they occur working from left to right. So we're going to look at some examples. Some helpful hints: write each step below the previous one. This makes it easier to follow. Copy everything in each step, just kind of in general. There's no magic in math. Things should not be mysteriously disappearing and reappearing. Make sure that you have everything copied down because it's easy to lose things, especially things like negative signs. And work one step at a time and don't skip steps. Many problems require several steps, and if you make a mistake on one step, that'll lead you to get the wrong answer. So take your time, don't rush, do one step at a time, and you'll get the right answer. So we have 7 plus 5 times x minus 4 to the third. We're evaluating that for x equals 6. This is example 1. It's on page 3 of the textbook. So evaluate means that we plug in 6 for x. So we're going to have 7 plus 5 times 6 minus 4 to the third. We do the parentheses first, so 6 minus 4 is 2, and then we do 2 to the third before multiplying by 5. 2 to the third is 8, and then we multiply before adding, so 5 times 8 is 40, and that gives us 7 plus 40, which gives us an answer of 47. The next problem is checkpoint 1 in your textbook. What you should do now is do this problem in your notes, or if you've printed off these pages, you can do it right on this page. And then you should check your answer in the solutions PDF file that's uploaded on Blackboard. So pause the video, do this problem right now, and check your answer before continuing. We're going to do one more example here with order of operations. This one we don't have any parentheses, so we can do exponents first. So 2 squared is 4. Everything else I just copy down. Minus 36 divided by 3 squared is 9 times 4 minus 7. Now this is what I was talking about with multiplication and division. It's tempting to multiply 9 times 4 next and then do 36 divided by 36. But the division here comes first if we go from left to right. So I do 36 divided by 9 before multiplying by 4. 36 divided by 9 is 4, and 4 times 4, and then minus 7. Then I do the multiplication next. 4 times 4 is 16, and then all I have left is subtraction. 4 minus 16 is negative 12, and then negative 12 minus 7 gives me an answer of negative 19. Next, we're going to talk about simplifying algebraic expressions. And we're first going to define like terms. Like terms have the same letters, and each letter is raised to the same power. So first we're going to identify, are they like terms? If so, add them, and if not, why not? So number 1, we have 2x plus 3x. Those both have an x with no power on it, or you could say a power of 1. So that means they are like terms. And when we add them, we add the numbers in front, and the variables don't change. So this is going to add to 5x. Basically, we're saying we have 2x's plus 3x's. That means we have a total of 5x's. Number 2, 4x squared plus 9x squared. They both have x squared, so they're like terms. We add the numbers in front. 4 plus 9 is 13, and we have a total of 13x squareds. Number 3, 7x plus 2x squared. Now we can't add these, they're not like terms because one is x and one is x squared. So no, because they have different powers. Number 4, we have 2x plus 5y. Those are also not like terms because they have different variables. One is an x and the other is a y. Same thing for number 5. They're both squared, but because one is an x and the other is a y, we can't add them. They are not like terms. Number 6, they look a little bit different, but these are actually the same thing because remember that in multiplication, order doesn't matter. So this is 3 times x times y. If we have variables right next to each other, that means multiply. This is 4 times y times x. We could easily rearrange these into 4xy or rearrange this one into 3yx. So these are like terms. They both have an x and they both have a y. And so when we add them, we get 7xy, or we could write it as 7yx. Generally with variables, we write them in alphabetical order, so you would probably see this. But if you entered this into MyLab Math, that probably would be fine as well. Number 7, they both have x and y, but as you notice, we have x squared in the first term and we have just x in the second term. So that means they are not like terms. So they have different powers on the x variable. It doesn't matter that they have the same power on y. If one variable has a power that's different, then that makes them not like terms. And lastly, number 8, xy squared plus 6xy squared. They both have x and they both have y squared, so they are like terms. When we're adding these together, what we have to do is put an invisible 1 in front of the xy squared term. 1 times anything is itself, so if there's a 1 in front, then we usually don't write it. But we need that 1 in order to add them together. So we would add the numbers in front. That would be 6 plus 1, and that would give us 7. So 7xy squared. Lastly, we're going to do some more simplifying, including problems that will require the distributive property. We use the distributive property to remove any parentheses and then combine the like terms. So for number 1, we have x's and y's. One thing that you might do is either use different colors or different underlining to identify what the like terms are. So if I have 4x minus 7x, that's a total of 4 minus 7, or negative 3x's. And for y's, I have 5y plus 2y, so that's a total of 7 plus 7y's. So my answer would be negative 3x plus 7y. For number 2, I have parentheses, so I need to distribute first. So distributing means I multiply each term in the parentheses by the number that's in front. So that gives us negative 8n. Negative 8 times negative 3 is going to be plus 24. Then I need to distribute this second set of parentheses as well. That will give me plus 2n and plus 2. And now I would go through and combine like terms. In this case, I'm going to be combining the n's together. Negative 8 plus 2 is negative 6. And I'm going to be combining the numbers together. So these are numbers without a variable. 24 plus 2 is plus 26. This is example 8 from the textbook section. Again, we're using the distributive property. This one is just a little bit more complicated because we have exponents. I'm going to distribute into both sets of parentheses. That's going to give me 12x squared plus 24x for the first pair, and 40x squared plus 30x for the second pair. Then I would go through and combine my like terms. 12x squared plus 42x squared. 12 plus 40 is 52x squared. Remember, we're not adding the exponents here. We're just combining the numbers in front by adding, and then the exponent, whatever it is, would stay the same. Then we would add 24x plus 30x. That's a total of 54 x's. So next you should do checkpoint problem number 8. You can do it either in a notebook or you can just write it right on this paper if you've printed it out. And then you should check your answers in the solution file that you'll see on Blackboard.